is my pleasure to be here. I'm greatly honored for this opportunity to present. And today, my presentation will be structured kind of in two parts. As you can see, I wear two hats, well, at least two hats for the purposes of today. I work for the company called ST Microelectronics, and at the same time, I'm a chair of the newly formed standardization working group, a project called P2413, Architectural Framework for the Internet of Things. So I will give you two perspectives on architectural framework, and we call it a market-driven architecture. Why market? Because we don't need standards that miss the mark and are created just for the sake of creating standards. We need something that can help us to move the market, move the industry, and do something positive for us. So let's start first with where I work. I work for ST Microelectronics, as I said before. It's a global semiconductor company. We are present pretty much everywhere, probably #1 semiconductor company in Europe, and we make just a little bit over $8 billion a year based on 2013 numbers. So it's a fairly large company, very diverse, with 45,000 employees worldwide, with 9,000 people working in R&D alone. So as you can imagine, we do a lot of research in various areas, and Internet of Things is one of the key areas of research today for ST as a company. So let's talk where you can find our products, and that will give us a little bit of an idea why I'm interested in Internet of Things and why ST is interested in Internet of Things. Today, you will see MEMS in pretty much every single device that you use. If you use a cell phone, it's most likely that it has in a smartphone our MEMS devices. If you look digital, if you use digital entertainment at your home, most likely that in your set-top box or television set, you will have devices from ST Microelectronics. If you drive a car, most likely that some of the electronics in this car is coming from us. Smart power products enabling cost reduction and LED lighting, also coming from us. And of course, our microcontrollers, STM32 family, powers a lot of IoT devices today, a lot of applications in the world. So let's start with the definition. What is Internet of Things? How can we define it? We need to understand what it is before we can actually start analyzing and digging down and trying to define the architecture. So we define Internet of Things as things that leverage the Internet to become smarter. And there are two categories of those things that we need to look at. Existing things that we can actually augment with intelligence and make them smarter, or new things that are created based on the platforms of the technology available today to augment our lives to make them better. So that's kind of a duality of Internet of Things that we need to focus on, and while we're defining our strategy and approach to the market in general. We also need to be cognizant of major megatrends. What is happening today around us in the world? What is driving our development? What is creating the platform for technology to build upon? Well, let's look at 2030. It is predicted that in 2030, we'll have 8 billion of us living on this planet. It's a fairly large number. Well, an interesting component of it is that more than 60% of that 8 billion will be living in the cities. So urbanization is certainly a very strong trend, and this trend probably is also associated with the rising energy consumption. We need to be cognizant of that. Another interesting element of it is that 65+ generation will nearly double by 2030 and will go from 7% today to 12% then. It's a very significant increase. Why is it significant? Well, if we talk about healthcare costs, we're talking about cost of living at home, they're increasing. And if we can allow people to stay home longer without using special medical facilities, we can probably not only reduce the cost, but also improve the quality of our life. And guess what? That is where one of the greatest promises of Internet of Things lies. It's the ability to enhance our lives and enhance our ability, prolong our ability to stay home and be independent. Scarce resources. It's not a secret that geopolitics, fluctuating oil prices, finite amount of natural resources and fossil fuels force us to think about energy efficiency and alternative energy sources. We need to find ways how we can harness solar power, wind power, hydropower, and other forms of power, and of course, new sources of energy to create a platform upon which we can actually not be only more energy efficient, but less dependent on fossil fuels. And of course, climate change. We don't want to affect the planet in a way that will destroy the future for our kids and grandkids. We would like to make sure that the impact of our manufacturing, of our societies, our cities, our urbanization trend is not destroying the planet we're living on. So we need to be cognizant of how to make it possible to become more efficient, not only from the point of view of power consumption, but also more efficient from the point of view of reducing our environmental impact on the rest of the planet and preserving it for our kids and grandkids. So we talked about the Internet of Things. We talked about those things augmenting our lives. So if we start looking at wearable devices, smart me, they allow us to monitor our vital signs and become smarter about who we are. If you look at smart home, our home can become more cognizant of where we are, what we're doing, what our living patterns are. As it has been proven already by companies like Nest and others, there is a huge value in trying to analyze our living patterns and adjust how our home caters to our needs, providing greater level of comfort, but at the same time using less energy for that. It's possible, because if we know our occupancy, our movement, if we know what we're doing within the home, it becomes very obvious how to accomplish that. Smart city. Smart city becomes a more important component of our future life, because as urbanization continues to progress, more of us are aggregated in the same city. We need to be cognizant about safety, security, how we light those cities, how we dispose garbage, how we deliver fresh water, and many other things. And this is exactly where Internet of Things can help, because distribution of sensors throughout the environment in which we exist can tell us not only about what we need to do with this environment, but how we can improve our own patterns, how we can optimize traffic, how we can reduce congestions in the cities, and many other things. Smart car. I don't think I need to talk a lot about it. After such a wonderful presentation made by Daimler here on Tuesday, it was fascinating to see the self-driving car and the car of the future that actually also talks about the comfort. That was very interesting. It's not about the efficiency, but it's also about the comfort. The cars that gives you back your commute time, the cars that can take you from point A to point B without your interaction with the road, and essentially give you an opportunity to either socialize with somebody who is in the car with you, or read a book, or listen to the music, or watch TV. It sounds very futuristic, but as it has been proven by Daimler just on Tuesday morning, those cars can exist. And as you could see, it even had driven down the Las Vegas Boulevard. I don't know if you have seen this YouTube video, but it's fantastic, it's phenomenal. And it's a nice looking car too. What is important to notice, it's a humanization of the technology. When we talk about the Internet of Things, it's not only the creation of the devices for the sake of the devices, it is the creation of the environment that learns about us, interacts with us, and does something behind the scenes that makes our life better, without making too burdensome on ourselves to do some things that we wanted to do. That type of humanization of the technology that extracts meaningful analytics out of the data that is collected by sensors and uses this meaningful analytics to create something very interesting. That is a huge and promising component of Internet of Things. Embedded intelligence that is becoming more and more possible today to be embedded in our clothing, in our shoes, in our watches, in our heads, and just about anything around us is something that enables this vast and wonderful trend where things can talk to things and decide behind the scenes what is needed to be catered to us, what is best to be given to us, and how they can improve our lives through that. And of course, all of that is combined with the smart energy use, because once we can become more cognizant of what we do and how we do and learn about our patterns, it becomes easier to optimize our environment to reduce the burden of energy consumption in everything we do. And you can probably notice that I talk a lot about energy consumption. Why? Well, energy consumption is important. We talk about intelligence. We're talking about 50 billion smart things by 2020, 2025, maybe 70 billion depending on the source. Think about it this way. Even if the consumption of a single device now added to anything is 10 milliwatt, do the math. Multiply 50 billion by 10 milliwatts. How many megawatts of power is that to provide the source of energy to that efficiency? So for us, designers of the silicon, and by the way, silicon is a key enabler component today for future economy. Without the intelligence, without chips being built into something, we cannot create this future economy, we cannot create this future world. So we need this technology. So think about how much power it is required in megawatts to power those future Internet of Things, this 50 billion, 70 billion, 100 billion devices. We need to learn how to make them very energy efficient, how to consume the energy in a very efficient fashion when we transmit data from point A to point B. Because keep in mind, one of the interesting opportunities with Internet of Things is the ability to collect tremendous amounts of data. So while we're transmitting this data, we consume power. So we need to be also cognizant of how to reduce or optimize power consumption during the transmissions. So networking technologies that are power efficient and aware of the power distribution are becoming very, very important. That's the challenges that we silicon guys are dealing with today. And I have to proudly say that we're succeeding. We do a lot of very good things, and devices become lower and lower power and becomes more and more possible to embed them in various fabrics. But look at this chart. Look how nearly $300 billion semiconductor industry effectively affects 71 trillion of GDP worldwide. It's a fantastic build-up, but it kind of gives you a perspective how a building block, a component, can enable the whole world to go forward and actually operate smoothly. So we talked about things that are augmented. We see evidence of that every day of our life today. It used to be the case that watches were used to tell the time. Now, they tell us what to do. If you look at the introduction of a new breed of smartwatches that become fashion accessories, and even will.i.am came out with a smartwatch that is becoming a fashion accessory and tells you what to do and how to do it. A power outlet used to be used just to get power from it. Now power outlet is becoming something that not only tells you how much energy you consume, but using power line communication, riding on the top of the same wires, you can essentially transform every power outlet in your home into a networking port. So your home becomes this gigantic Ethernet switch. Look at those Pandora bracelets. We used to wear them as just a fashion accessory. Now, not only they remind you what is close to our heart, but also can tell us about the condition of our heart and improve our heart health, because it can tell us about our blood pressure, pulse rate, and what we do when we exercise. Well, needless to say, there is a huge evolution in what used to be an eyewear. Google Glass has transformed how we perceive our eyewear. Augmented reality is becoming a reality, and today our glasses are not only something that helps us to see better, it can help us to understand the world around us in a much better fashion, because we get so much more augmented information about the world around us through the smart eyewear. It is impossible to imagine any silo, any industry, any vertical without being affected today by the augmentations that Internet of Things can potentially bring to it. If you look at the smart city, as I mentioned before, we have opportunities to reduce traffic congestion simply because we know traffic patterns and we can suggest what needs to be done with it. I was fascinated when I read about one of the developments in the city of Boston, which had a pilot program based on a very simple premise. As you know, for those of you who live on northeast of the United States, every time the winter is over, potholes appear, and it's probably very difficult to drive through the city without having a tire blown at least once in a season. It's unfortunately the reality. I live in New Jersey, and whenever I go to New York, I end up with consequences. So what City of Boston had done, it's very simple. It's actually remarkably simple when you think about it. They have created a program where you can download an app on your smartphone. And for as long as this app is enabled, it tracks GPS and accelerometer. And whenever your smartphone detects either a jolt associated with you hitting pothole or movement that is associated with you trying to avoid pothole, It's an alert that is getting into a database of the city of Boston. So through the statistical collation of this data, you can see that you can actually detect not only the size and severity of potholes, but you can also figure out the priority in which they need to be fixed, depending on the most pervasive traffic patterns in the city. It's remarkably simple, right? But it's fascinating how that simple application can change essentially number of tires that people have to replace in any given season. So that kind of impact that is based on technologies that are already available, but is really enabled by something that is fundamentally important to Internet of Things. If I ask you, what is in your opinion the most important thing about Internet of Things? Does anyone have an answer? Yeah. Security. What else? You're close enough. But why is security so important in your opinion?
People will be attracted to stuff that works. They'll keep it if it connects up enough so that it's useful. But they will keep it long-term only if they can trust it. Nobody wants their body hacked. Nobody wants their house hacked. Full stop.
I think you're very close to the answer. But I think you stopped short of actually explaining why trust is so important. Look at the automated systems. We have had them probably for hundreds of years. You can trace it back to even steam engine control. But up until now, up until Internet of Things revolution, all of those verticals that I'm describing on the slide have existed in their own confine. And it's fairly easy, I mean, not without a challenge, but it's fairly easy in relative sense to create a trusted system that belongs to you. If you have your own sensor embedded into something, it's your own control application, it's your own communication links that go there, it's very difficult to hack this system, as you said, without actually physically tapping into it. So the level of security and trust is pretty high in this application. So what changes? What changes with Internet of Things? Well, it's a horizontal nature of Internet of Things that changes everything. In this example I just described with a smartphone, what is interesting to note is we have an open platform. If you think about a thing in Internet of Things, smartphone is a great example. It's an open platform that has sensors, has the ability to visualize data, process data, but now how many services can tap into this platform? Endless number, including a hacker. So with the horizontal nature of Internet of Things, it is very important to create security and trust that actually caters to that horizontal nature. So the data exposed to various services is exposed not only based on what those services are asking, but also what is the identity of who is asking, what is the identity of the device that is providing this data, what is the identity of the data, can it be authenticated, can it be trusted, can it be protected, can it be safeguarded. So that horizontal nature, that breakage of vertical barriers that exist among various silos is what creates this new and absolutely important need for the trust, security, we call it quadruple trust, identity management and many other things. So if I go through the slide and I review all of those verticals we talk about, the horizontal nature is what will come across in every one and every single example given here. And this horizontal nature is in fact in what we're trying to accomplish. We're trying to create unified platforms, and upon those unified platforms, we're trying to build a new breed of devices that actually have the ability to leverage data, information, analytics, all of the smarts that can be created in other verticals, traditionally not connected together. That horizontal nature is a very unique feature of Internet of Things. And of course, as a consequence to that, we have now new requirements for security, trust, and everything else. So I hope you're in agreement with me. I can see that. Great, thank you. So what is the building block? We talked about billions of things. 36 billion based on one source, 50 billion based on another source, 70 billion based on another source. I don't think we can argue what exactly the number will be, but probably it's completely true and everyone is in agreement that the number of those things will be enormous. So what are those things that we're talking about? If you look inside of this little thing, if you try to drill down, it has sensors, microcontrollers to provide smarts, communication components to be able to exchange information. It all has to be wrapped into the envelope of the smart power. And on the top of it, we have to have security. That is, in our opinion, a definition of Internet of Things thing. That's the thing that will make Internet of Things work. All of those components have to come at low cost. They have to be very simply implementable. They have to be very small in power consumption and size. That is what is going to make Internet of Things work. So if we start drilling down even further, obviously, we have a lot of different sensors. We have a lot of low-power brain microcontrollers. We have sensor fusion devices that can allow us to leverage sensor hubs to create a lot of sensory and pre-analytical data extraction, processing closer to the border, to the edge of the device and edge of the network. There are many, many, many functions that go into it, and I can probably spend 2 hours just on this slide alone telling you what we, as a semiconductor company, think about building those things and how we go about it. It's a fascinating topic, but perhaps we can leave it for another conversation, another conference, because in itself, it will probably take me a few hours to get through. So now, I would like to switch gears a little bit, and instead of wearing my ST hat, I will wear the hat of the chair of P2413, Standard for Architectural Framework of Internet of Things. It's another perspective to look at the Internet of Things. I usually like bring into the room my pet elephant. Why a pet elephant and why blindfolded men? Very simple. Internet of Things is such a multifaceted development. It has so many different verticals combined in it. It has so many different angles. So depending on who you are in your professional life, depending on what you do on a daily basis, it will be different perception of what Internet of Things is. So it truly is blindfolded people trying to touch this elephant, because depending on what you touch, it could be, it's the leg of an elephant, could look like a trunk of a tree. It's a tip of, it could look like a spear, or tail could look like a rope, and the list goes on. So one of the things we need to accomplish, trying to create an architectural framework for Internet of Things, is to figure out how to mold and meld all of those different perspectives into something that can be under the same umbrella and understood by everybody. So we can really create a true cross-platform implementation for the architectural framework for the Internet of Things. A bit of a history. I don't know how many of you know, but IEEE has launched IIT Initiative. IoT Initiative is a great development that has, in my opinion, brought a tremendous value to academia, industry, and all of the stakeholders that today try to work inside of the Internet of Things. We have done a sequence of worldwide workshops. We have hosted IoT roundtables where we gathered industry leaders, and we actually derived a lot of value from that. And by the way, if you guys don't know, the chair of this initiative, Roberto Minerva, is sitting at the table over there, and if you have any questions about this initiative, please do stop by and talk to him. You see his hand is raised. Fantastic. So I think it's very fortunate, because under the umbrella of this initiative, we arrived at the conclusion through all of those workshops and seminars, marrying engineers, researchers, business people. We arrived at the conclusion, we need an architectural framework. We need a blueprint of how to actually create a framework for the Internet of Things. And as a result, we decided to start our P24 standard. Why is it important? Well, if you look at any industry, any technology, you will notice that historically, any technology starts as an island in the ocean. Somebody comes up with an idea and says, aha, I would like to build it. But usually great ideas are not born in a vacuum, and they're not born by themselves. Somebody else nearby says, wow, it would be great to solve this problem, and maybe I'll go about it in a slightly different way, and I'll create my own solution. So all of a sudden, you start seeing those islands popping up everywhere, doing something. I mean, remember, if you go back and you start looking at, as an example, development of cellular phones. How many different technologies were looked upon and even implemented at the beginning? Well, we still have some garden variety here, but there is a unification going on. And people tried and tested and did something, so we had a lot of islands. But then at some point people realized, well, we need to drive towards the economy of scale. We need to figure out how to work together, how to build bridges among those islands, so we can actually create a vibrant ecosystem. We can create an environment in which everyone can do something and derive some kind of value out of it. So bridges starting to be built among those islands. But then as we move forward, and once again, mobile phone industry, cell phone industry is a very good example, we need to have a greater degree of unification. We have to have the ability to unify the technology so the economy of scale really can prosper, kick in, and benefit everybody. Users, developers, manufacturers, everyone benefits from the economy of scale. So we start seeing the development of this huge landmass that now replaces those islands and creates this unified and great environment upon which we can build our future smart cities. So that's exactly the life cycle of technology development. And an overarching architectural standard usually comes at the time when the industry matured enough in a sense that it has proven the need for the technology. But now it needs a way to implement this technology in such fashion that it can be scaled up in volumes, scaled down in power consumption and cost, and make it pervasive enough so everyone can benefit from it. Another aspect of Internet of Things. Internet of Things combines two historically disjointed elements: operational technologies and information technology. If you look at the guys who deal with heavy machinery, mining operations, it's not apparent from the first glance that they know how to harness the power of information technology running those giant trucks in a canyon where the excavation is taking place. But I can tell you, just recently at IoT Cisco Forum in Chicago, there was a fantastic presentation by a mining company that was exemplifying how embedding sensors in the trucks, in the drilling gear, into every aspect of a mining operation can not only improve the efficiency of the operation itself, but also create an opportunity for reducing the impact of mining operation on the earth around the mine, which is quite important because, as you know, sinkholes and other issues that arise when we excavate something out of the earth, when we take some volume of whatever it was there under the surface, we create dangers. So managing and mitigating those risks and dangers is very important. And that's where the marriage of information technology and operation technology, even in mining operation, can bring tremendously positive results. So what are the stakeholders that can benefit from this convergence of information technology and operation technologies? This slide is not all-inclusive. This is probably just a very good sample of different industries and various segments and domains that we can think about. But the reality of the matter is, every single industry we can think of, every silo of development we can think of today would benefit from the convergence of operational technology and information technology. And IoT is effectively the enabler of that convergence, enabler of that to happen. So why did we decide to create P2413 architectural framework standard? Well, there are several goals that were set by the groups that launched the standard. Of course, accelerating the IoT growth, the growth of the market, was one of the first and foremost important goals. We need to help IoT market to develop fast, painless, and move forward rapidly. We need to define an architectural framework that can meet needs of various domains. Remember this example with a smartphone and how it can be used for pothole detection? Very similarly, we would like to see the platforms deployed today in IoT world to be applicable across multiple verticals, and therefore they need to meet multiple application domains. Well, another one is the increase of transparency of system architecture implementation, increase of trust, providing the way to benchmark performance of various technology, in the IoT environments. And of course, provide a way, a platform for accomplishing security assessments, because I fully agree with the statement earlier from the audience. Security and quadruple trust will be something that is utmost important, and without it, IoT will never exist. And of course, one of the goals of this group is to leverage the existing body of work. So it's not the goal to let's create a new standard because we would like to have a standard under the IEEE name. Not at all. What we would like to do, we'd like to create a unification platform for the standards development here in the domain of IEEE. So if you look at the scope of the standard, it defines domains, it defines abstractions, and it identifies commonalities among different IoT domains. And it is also an architectural framework that provides a reference model that defines those various relationships among the domains. And also common architectural elements, so we can actually enumerate what can be reused and redesigned every time we go about it. And of course, reference architectures that builds upon the reference model, defines basic architectural building blocks, the ways they can be connected in a multi-tiered system, and addresses how to mitigate architectural diversions, because we fully understand that depending on the domain, you will have certain specifics that need to be addressed, and divergence will be mandated by certain requirements. And now we're talking about quadruple trust. Last but not least, this point is absolutely important. It is not just the ability to encrypt data. It's not just the ability to say, okay, a unique ID of this device is XYZ. No. It is a quadruple trust where essentially protection, security, privacy, and safety can all be folded into the same platform, and elements of the platform can work in harmony, enabling ubiquitous and harmonious operation of all of those elements. That's very key. So methodology. We start from identifying commonalities and verticals, and potentially many, many verticals. We're starting addressing the relationships among security requirements, energy efficiency requirements. And by the way, when we talk energy efficiency, it's not just energy efficiency of the silicon itself or device itself, it's energy efficiency of a transmission of the data, which is very important, because in most cases, in many cases, IoT devices will spend more energy on transmitting or receiving data than actually on processing or sensing it. Service requirements, how quickly the data needs to be delivered, how tolerant we are to latencies, how tolerant we are to potential loss of information, and many, many, many other things. And application-aware routing, that is a very, very important element. I don't know if you have heard about IEEE 1905.1 standard, but in my opinion, this is the first an excellent step towards creation of the environment where application actually doesn't even know which physical interface it communicates over. The interface itself defines which communication technology to use. And 1905.1 was created about a year ago, and as the first implementation, it was looking at 802.3, 1901, 802.11 technologies, and Mocha technologies. Now the group is working to extend it to other communication technologies. But to me, this is kind of a marquee event because it defines that application-aware routing, as we go forward, will become more and more important element of IoT type of networks. Networks that by nature need to be hybrid and combine many communication technologies together. Of course, we need to link features and components in existing standards and a top-down view to understand how they can help us to go forward and do a lot with what we have today. And by the way, if you look at the portfolio of IEEE standards today related to IoT, the number is probably exceeding 400 already, standards that are relevant to the IoT development. Identifying design choices for IoT will be important. Match requirements with specific domain structures and relevant design choices. Develop data profiles similar to what has been done with 2030.5, where smart energy profile was developed to essentially abstract energy-related data and provide for a very flexible environment in which multiple stakeholders can work and do what they need with the data and controlling of the environment. And of course, unification of the standardization efforts today is very important, and that's one of the things we're trying to do under the umbrella of this group. The group has already done quite a good job trying to create a tremendous interaction with other standards development activities around the world, with 82.24, with ISC SG8, with 1M2M and other organizations. That's very important, and as we're talking about breaking verticals, we also have to break verticals in the standardization space and make sure that standards work in concert and together. A membership of the group is growing. Today we have 23 members, and as you can see from the slide, probably it's a very good collection of most of the companies today involved in IoT, especially in the industrial side of the IoT. You see companies like Alcatel-Lucent, Cisco, Emerson, General Electric, Honeywell, Huawei, and many others. And if I missed one company, please look at the slide, because that to me is very important. Creating a vibrant ecosystem, the environment, and everyone collaborating together is absolutely important. To be efficient, the group has subdivisions and sub-working groups that work in concert and continues the work among the plenaries and continue to push this progress forward. And we plan to have a standard developed in 2016. The next meeting of the working group will take place in Taipei, end of this month, 22nd and 23rd. So if you would like to join us in Taipei, very welcome. Would be excited to have new members. And in conclusion, it's very simple. 2413 recognizes the evolutionary and transformational nature of Internet of Things, and that's why we started this work. Convergence is something that breaks verticals, creates this new type of the environment in which quadruple trust is needed. We're trying to extend our architectural framework to provide coverage for many, many verticals and many silos. And we continue to deepen our industry engagement, because that's the only way we can create something that is viable to the industry. And it is an open community. You're welcome to become a part of it. And with that, I thank you and welcome your questions.
Thank you, Oleg. Anybody have questions? Scott?
Hi, good morning. Thank you for that presentation. It's absolutely brilliant. I have a question about IoT as a general. IoT at the moment is very much on the top of the sort of Gartner hype cycle. When do you think that IoT is going to start to deliver technologies and procedures that are integrated into the sort of generalized consumer households, such as 802.11 now is, where my father has a Wi-Fi router? At what point do you think he is going to have IoT in his house?
Well, first of all, I would like to thank you. Not that often that I get brilliant as a comment to my presentation, so I sincerely appreciate that. And also thank you because it's a fantastic question. You're right, IoT can be perceived to be at the height of the hype cycle. But we need to start looking at what IoT is, right? And certainly if you look from the point of view of CES, a lot of hype is associated with a variety of verticals, smart home. A lot of companies are trying to introduce products in that domain. But let's leave that aside for a second. Smart car. While it is not very hyped, but connected car is in the heart of the IoT development, okay? Industrial IoT. Remember this example of a mining operations that I talked about. Remember this example of a city of Boston using effectively a smartphone to identify potholes. That's IoT as well. So I think we trace different S-curves depending on which industry segment we're looking at. And in my opinion, it's fair to say that IoT in the industrial space, while it doesn't have this hype bump at the beginning, is doing excellent progress and being deployed today on a very, very large scale. Because if you look at lighting as a service as an example, pilot projects in many of the cities. You look implementations in Barcelona, Chicago, and many other Guadalajara cities that are pioneering IoT deployment. Those are very steady and very fast progressing projects. They're less visible because I guess they're not as attractive from the point of view of being written about, because it's not as close to the consumer home as an example, a wristwatch could be or a set-top box. But those are major activities that are underway, they're very strong, and they're progressing forward. It's happening now. But let's now go back to the wearables and consumer side. I think what we struggle with today, and this is my personal perception, is smart home notion has been out there for decades. In fact, I think the first smart home demonstration was, what, 1956 or something like that, if not earlier. What is missing today is the technology has to become invisible to us, to become akin to magic. And that hasn't happened yet, because number one, unification hasn't happened enough to blend all of those devices, such as an example, your Roomba robot and set-top box and thermostat and many others, so they can become a single platform that actually works somewhere outside your conscious perception and does things for you that you would like to be done. When will it happen? I think we're on the cusp of it. I think with everything that is happening today, and that's where I like this analogy with my islands, you see that Google, Apple, and others are trying to do things in that domain. I hope that in the course of the next 2, 3, 4 years, we will see convergence and unification of that.
Just to follow up, do you think, therefore, based on what you've said, that having this sort of ubiquitous name of IoT actually in many ways is misleading, because it's not really, there's so many sort of these different subsections, and the word IoT, or the acronym IoT, really stops to have meaning? Do you think there should be some other name for this?
Well, it's an interesting question that you're raising. When we're talking about IoT, we often draw this crossbar picture. When we have a variety of verticals that exist, and it's wearables, it's medical, it's whatever, in heavy industry, and then horizontals, which is communication technologies, processing technologies, security, quadruple trust, and other areas, which are common among them, could be common among them. Does it need to be an identification of devices for a specific vertical? Maybe, but this is more of a branding question. I think two things that identify IoT in my mind is a horizontal nature, it's basically breaking of those barriers, and convergence of OT and IT. So from that point of view, the definition of IoT to me is ubiquitous. Whether it's applied to wearable, medical, self-driving car, or a huge mining machine, it's the same thing. We're using the same basic and fundamental blocks.
Thank you. My name is Narisa Chu, and I was encouraged by my colleague, Mike Asnardo, sitting right next to me, to ask this question. Basically, I'd like to get back to the trust issue. I admire the goals that you have listed there. The first one talks about accelerating or shorten the time for the introduction of IoT. But we all understand trust, particularly when it comes to e-health and many of the programs you mentioned, financial applications. Trust has to be there, and trust cannot be built overnight. You cannot accelerate that. You have to prove it. So what would be the standards organization address that issue? Thank you.
Well, first of all, thank you for your question. It's a great question, and I understand that anything goes wrong with my answer, your colleague will be to blame, right?
This answer is going to be very long.
Well, but jokes aside, it's a very good question. The reason we created this work, the reason we started doing this work, and by the way, the standard was only, the development work was launched July last year, because we felt we need to create the platform of this quadruple trust to be able to start even pilot projects, especially in the industrial, medical, and automotive spaces. And when we say acceleration, what do we really mean by acceleration? If there is no framework, there is a hesitance to even start pilot projects. So by creating the framework within which we can start testing various approaches to quadruple trust, we're helping the industry to move forward faster. That's the acceleration factor. And I absolutely agree with you. It's necessary. But one aspect to look at, if we have many disjointed efforts, we have many developments that are confined to silos and not reused everywhere, first of all, we'll spend more time figuring out which one to use, which one of them can be trusted. And I can tell you, coming from the industry, and I used to be on the telecom side 10 plus years ago, it's impossible to test a variety of technologies. It's too expensive. We don't have enough resources to accomplish that. That's why we need the industry to come together, agree on a unified approach, and help people who deploy, whose job is to make sure that it works, verify it. I hope it answers your question.
Well, my goodness, this is so much information in such a short period of time. We actually have run out of time for questions, but I just want to make a couple program notes. There is a panel session today at 4:30. It's in your program, dealing with IoT, and probably have interactive. And as Oleg mentioned, Roberto Manera, who is the IEEE IoT Initiative Chair, will actually be speaking following the break, 10:30 this morning in room N256. But I believe Professor Hasse has a presentation to make. Thank you so much, Oleg.
Well, thank you very much. In conclusion, I also would like to say one more word. IEEE also has started the Internet Initiative, specifically focused on the policy side of Internet safety and security. So stay tuned and follow this initiative. You will learn a lot. It's key to IoT and everything else we're doing. Thank you very much for the attention and opportunity to present. Thank you.
Thank you very much for your interesting speech. Thank you very much.